So hello, this is a quick look at the axis of an ECG. The important thing to note is if you don't get ECG axes now, it probably doesn't matter. There aren't many conditions where it matters that much, particularly at our level. However, it can help you to discover that something is wrong. Maybe the changes are subtle and the only thing you can clearly see is an axis deviation, or it can help you to diagnose something like PE, where you've got some right heart strain. It can sort of add to your clinical suspicion, as PE can come with a number of different ECG changes. So basically, I just wanted to quickly show the system that I use. I know there's lots of systems, but I don't like the other ones because there's too many different things to worry about. I like to keep it as simple as possible. So essentially, what we're looking at is the two particular leads. Lead 1, which as you can see goes straight across in a rightwards fashion, and AVF, which is a straight down. These two are perpendicular to one another. I forget about AVL 2, 3, and AVR. I know that other systems do include, say, 1, 2, and 3, or 1 and AVL, and those systems are fine if you understand them. But for what I like to show people, 1 and AVF is the easiest, in my opinion. And basically, you just need to do a little bit of vector addition to work out whether the axis is normal, left, right, or in this quadrant here, which in this it says far right, but most of the time you'll see it written as extreme axis deviation or northwest, because obviously this is the northwest quadrant if you're looking at a compass. So that can be a extreme right deviation or extreme left deviation. It doesn't have to be right. So what do we do? So basically this is one of the other systems, 1, 2, 3. But as I said, I don't really like that system very well. So basically if you've got lead 1 and lead AVF, you just need to see whether it's positive in one, i.e. to the right, or is it negative in lead 1, i.e. to the left. And then you need to look at, is it downwards, which means that it's a positive inflection in AVF, because if it's positive, it's going down this arrow towards the F, the feet. And if it's a negative inflection in AVF, then it goes upwards. Okay? So if we look at this ECG here, we can see that in lead 1, we see a upwards inflection. And in lead AVF, we see an upwards inflection. So if lead 1 is upwards, it means that it's going from towards the right. And if AVF is positive, it means it's going down towards the feet. So it's going across to 1, it's going down to AVF. And so when we add these vectors together, we end up in this quadrant, which is always normal. It doesn't matter whether 1 is a bigger inflection or AVF is a bigger inflection or the same. This quadrant's always normal. Okay? Moving on to this example, apart from the fact that there's the bradycardias and the hard to spot P waves, we're just looking at the axis deviation. So lead 1 is negative, as we can see here. AVF is lead 1 is downwards deflecting and AVF is upwards deflecting. So what does that mean? It means that lead 1 being downwards deflecting is not towards the right, it's in fact towards the left. As we can see from this, that's always pathological. If lead 1 is to the left, it means we're either in the northwest quadrant or in the right axis deviation quadrant. Which one is it? Well, AVF is upwards pointing, so it means that it's down towards the feet. So we've got leftwards in lead 1 and downwards in lead AVF, so it's a right axis deviation. Maybe right ventricular hypertrophy, maybe right heart strain, who knows. Okay? This example, that's the one we just had. This example here, you can see an upwards deflection in lead number 1, which means that it's towards the right, and you can see a downwards deflection in AVF, which means that instead of going towards where it positively deflects, i.e. towards the feet, it's actually going upwards towards the head. And we can see that here again. So lead 1 is positive, however lead AVF is negative. So we're up in this quadrant. Now we get to a problem where some books will tell you as a sort of a general rule that this quadrant should just be regarded as left axis deviation. And it's not unreasonable because most of it is. From -30 to -90 is left axis deviation, and from 0 to -30, so only 1/3 of it is normal. Now, this is where the vector addition comes in. It's not relevant really for any other quadrant other than this one. So what do you do? So the deflection in lead 1 is, it's good to measure it, and I'm just looking at this closely. You can see the deflection is about probably 1, 2, 3, 4, 5, 6, probably about 2.5 or a touch more of the big squares. So let's say 2.5. And in AVF, the deflection is around 1, 2, 3 and a bit. So the AVF deflection is a little bit bigger. Okay, so what does that mean? In our lead 1, if we say that it goes towards the middle, if we say that that's the magnitude of lead 1, it doesn't actually matter. If AVF has the same sized deflection, then going halfway across here, and we go halfway up. So it's at 45 degrees, -45 degrees. So it would be a left axis deviation. In this case, in fact, AVF was even larger, so it would be even higher, closer to maybe -60. So what you have to do is you have to compare the relative heights. For it to land in this sweet spot here between 0 and -30, lead 1 needs to be the bigger deflection. If lead 1 is a big deflection, it goes further towards this point, and AVF, if it's just a small negative deflection, the overall angle will be somewhere between 0 and -30. But if they're the same, or if AVF is bigger, then it's definitely left axis. I would highly doubt at this level that we would be getting anything remotely close to -30. It's either going to be clearly AVF bigger than 1 or the same, in which case it's left axis deviation, or it's going to be clearly 1 much larger than AVF, and that's normal axis. So this just summarizes what we've been talking through, and I've just got a few examples to finish. So as we can see here, the normal is upwards in 1 and AVF, because it's going to the right and down. Both of them being negative leads you to the northwest axis, and then it's right and left axis. As I said before, some places just regard this whole quadrant as a left axis deviation. You can be a bit more nuanced than that, but that's how a lot of books teach it. So what is this? This is an example. I'll give you 10 seconds to work it out. What it is. Okay, so let's work it out. So apart from being a very ugly looking ECG, we can see that lead 1 is clearly negative. We can see that lead AVF is clearly negative. So we have the very bad extreme axis deviation into the northwest. Lead 1 is negative, AVF is negative, so we're in this far right or far left deviation. Second example, 10 seconds. Lead 1 positive, AVF positive, so lead 1 is pointing out to the right, AVF is pointing towards the feet, so it's in the normal quadrant, normal axis. This one, 10 seconds. Lead 1, negative deflection. AVF is a positive deflection. So lead 1 is pointing towards the left. AVF is pointing up. Is a positive inflection, therefore it's pointing down. towards the feet, sorry. So lead 1 left, AVF is positive, so we're in the right axis quadrant. And again, it doesn't matter about the relative magnitudes, it's always right axis. This is that summary point again. And this is the article from Life in the Fast Lane about bifascicular block, and it's basically the only time where it's really important to know the axis as far as we're concerned at this level, because it superimposes a axis deviation on top of a right bundle branch block to pick up a bifascicular block. And if you add a first degree heart block, you get trifascicular block. Otherwise, it's just a normal right bundle branch block, which has its various causes, which you can read up about. So from this perspective, it's good to check. If you do see a right bundle branch, then you should also check for the axis. Otherwise, don't stress too much. It might be worth half a mark, but if it's going to do your head in trying to open it, then I'd say don't worry about it. I'll leave you with that. This is fpnotebook.com, ECG Axis, but you can find this sort of diagram on lots of different Google images. Thank you very much.